Okay, now that you got your feet wet with exponentials and logs and you see the whole connection there, we can now solve these problems without trying to figure out how to get same bases. Because if I notice that's base 10, and remember when you see log written, if they don't have a little number right there, by default that is base 10. So if I actually did log of 10 to the x, and whatever you do to one side, if I took the log on one side, I have to take the log on the other side. What happens is this comes down, and remember what a logarithm is. So if I have log of 10, and remembering that that is really base 10 there, this is saying what would I raise this base to get 10? I think it'd just be 1, right? And so in other words, that piece right there is 1. Most students will say it cancels out, but that's what's happening, is that is 1. And then from here, I can just simply pick up my calculator and type that in my calculator to get that answer. So you have to pay attention to the base. Remember, the base when we write things as exponent is the big number. All right, so that right there is my base written as my exponent, and then typically you will see it written as I mentioned over here on a log. Now what if you have this e to the x? I know my e's ugly. 4.269. Well, we have to go back and remember what is e. Remember, that is ln, so that's the natural log. So all we have to do is ln e of both sides, ln of 4.269. And so you have to be careful that you find this ln on your calculator to get this answer, 1.4514. And remembering what's happening here, and we get our answer.